In this video, we complete step 31, non-aggregation methods. So we're at this portion. I have a comment here. It says non-aggregation methods. In a step above, we completed a bunch of methods that were aggregation methods. So just a little recap on that. An aggregation method is simply a method that returns a single value for every single column. So min, median, max, sum, these are all aggregation methods. They all returned a single value for every column, and the end result was a data frame that had one row and just kept the original columns for those that it could actually do the aggregation on. So these non-aggregation methods are essentially the opposite of the aggregation methods. These are a group of methods that will all work the same. They will all preserve the shape of the data frame. So there's no aggregating going on. So for instance, when you take the absolute value of a column, all the value, every single value is going to remain in its place. The only thing that's happening is that the absolute value of that particular value will be returned. So all of these, cum min stands for cumulative minimum, cum max cumulative maximum, and they're all listed over here. Cum sum, clip, round, and copy. So these all work. So they all have a similar functionality in that they will just sort of transform the data, but they won't aggregate. So the shape of the data frame will remain the same for all of these methods. So if your data frame has a shape of 100 rows by 10 columns, the final result will also have 100 rows and 10 columns. So if you notice, for all these methods, they are all implemented very similarly. There's a single line of code, and that is a call to the non-ag method. And inside the non-ag method, each one of them passes a numpy function, and that is the numpy function that the underlying non-ag method will use. So let's just take a look down here. They're all calling non-ag. They're all returning the result from non-ag. So it is this method, non-ag, that we are going to edit in order to complete this step. Okay, so as you can see here, non-ag takes two parameters actually. So it will take the function name, but it's also going to take this other very strange looking parameter, has two stars in front of it, and it's kw args. So there's two. So this is useful whenever there's other parameters that you want to pass to a function or a method. So we do have two methods here that will pass additional keyword arguments. So the clip method is going to pass two additional arguments, a min and a max. So this determines, how to clip the numerical column. Round is going to pass one parameter, decimals. So this is a Python way of Python gives you some flexibility when calling other methods, in that you can pass any number of extra arguments, or in this case keyword arguments, like this. So these two stars denote that all the extra keyword arguments that you pass to this non-ag method will be stored in this kwargs variable as a dictionary. So whenever we're making this call, actually a dictionary will be created and it will be assigned to this kwarg. So the dictionary will have a min as a key, and it will map it to lower, whatever value that is, and a max will be mapped to upper. So this is just Python's way of providing developers a way to pass around extra arguments, extra keyword arguments to methods or functions. Now, if there was just a single star preceding here instead of two stars, then it would collect the extra arguments as a tuple and not as a dictionary. So you wouldn't be able to give it keyword arguments here. You'd only be able to give it, say, just value, comma separated values, and those would all be collected as a tuple. Okay, so regardless, we are going to use this to pass these extra keyword arguments to the underlying NumPy function. Okay, so let's go ahead and complete this method. So we'll begin, as we usually do, by creating a dictionary, a new data dictionary, and then we'll just iterate through our underlying data dictionary. Now, one thing I have not mentioned yet is that all of these methods, besides copy, only work on numeric columns, or I guess you could make a case that some of them, like come in, could work on a string column, but for our purposes, we are not going to allow them, we're not going to worry about them working on a string column. So we're going to write an if statement here to handle this case. So if the data type kind is uppercase O, which stands for object, so if we have a string column, we will just not process this. Okay, so we will not process this. And we'll do one thing here, and we'll actually technically just make a copy of the underlying array, so it won't be equal to the exact array. And we honestly probably should have been doing that in some other steps, is copying the data so that we have entirely new data for different data frames. But anyways, this also allows us to make this copy method work as well. So this is the copy method. Actually, it does work with strings. The other ones don't really work with strings. So this will sort of allow us to cheat a little bit and have it work with the copy method. Now, otherwise, so if we don't have a string column, well then we're gonna do a calculation. So we will go ahead and take that function name, whatever we gave it. Now the first value to these functions will be the underlying array. So we're going to give it the underlying array, and then we are going to pass it this dictionary, this underlying keyword argument dictionary, and these two stars will allow us to pass a dictionary such that each element in the dictionary will be read in as one parameter equal to some value. So this sort of unpacks the dictionary for us within a function call. So let's just take this for instance. Let's say we call the round method. So our non-ag method gets past this np.round function. This np.round function becomes func name. So this is now equivalent to np.round. Value is simply the underlying data, the underlying NumPy array. And then kwargs here will simply be a dictionary containing this decimals mapped to whatever n that the user provided. So, and that will be unpacked within this function call, so it'll be exactly like calling np.round on this NumPy array with decimals equal to n. So the last thing we need to do is return our data frame, and we'll just give it new data. So that's all we have to do here. So just implementing this one single method allows us to complete all these other methods at once. So they all follow the same pattern. So we're taking advantage that they all follow the same pattern, and this one for loop should work for us. Let's go ahead and test this. And what is the test name? It's called, so they're all in the test non-ag class. So this is a totally new class. So test non-ag. And let's see if all of these work. So they don't. Okay, let's see here. Which one did it fail? Okay. Okay, so I see what happened. So there's actually, we can't just run all the tests at once. So, and that's because there's a couple other methods that rely on this non-ag method. So we need to test them individually. So it's a little bit of a pain here. So, but if we go in here, they should all have the same name. So let me they should all have the same name. So if I'm going to go back down here, let me clear this up. So they'll be called like test abs, for instance. Let's just test them one at a time. So that looks good. Test come min. Okay, that looks good. Come max. That looks good. Come sum. And then we can test clip. That has passed. And test round. And then test copy. All right, so it passed all those tests. So there's a few more tests in the non-ag one that will get run, and that's for the upcoming steps, which is why it failed in the beginning. Let's take a quick look in our notebook to see how this looks. So we have df. So if we do df dot, let's say, come min, so this will not work for any string columns. It will work for Booleans. So Booleans, are treated as, 0 or 1. So come in. It does not work if you. It stops working after you have a nan. So it just will fill out nans the rest of the way. And for weight, well, they're all 40, so that is actually the come min, the cumulative min. If we do come sum, well, name and state will be ignored. But height, once it hits a nan, it will stop accumulating. School, 0, 1, that works, and weight gets accumulated. So that looks good. So, the tests, we manually tested our data frame and it appears to work. And we formally tested it with PyTest and passed all those tests. So step 31 is now complete.